Here we're going to be doing some work with some special trig limits, namely the limit as x approaches 0 of sine x over x equals 1, and the limit as x approaches 0 of 1 minus cosine x over x equals 0. Those are our special facts that we're going to start from on these. This video is not going to explain why the sine of x over x, why that limit is 1, or why this one is 0. That's a different video. We're just going to do some problems taking these facts for granted and trying to sort out all the algebra involved in finding these somewhat complicated limits. Let's take a look at this first one. So we have the limit as x approaches 0 of 2 times the sine cubed of 3x over a negative 3 times x cubed. And what I'm going to want to do to solve this is to try to put it in this form, sine of x over x, or in this case, since we've got 3x, we probably want to find sine of 3x over 3x in there, or chunks that look like that, because anytime I've got a chunk like this, as x approaches 0, the limit of that is 1. Okay? So that's what we're going to look for, and it really just takes some algebra to manipulate that. First of all, I'm going to pull this 2 out, because you can take a constant outside the limit. It won't affect the problem. It's the same problem. So I'm going to rewrite this as 2 times the limit as x approaches 0 of sine cubed 3x over negative 3x cubed. Now what I notice here is I've got 3 sine 3x's on top. This is cubed. And on the bottom I've got 3 x's, and I've only got 1 3. I've also got this negative sign that I don't really need. In fact, I'm going to get rid of that negative sign right now by pulling it out here with the constant. And what I need is 2 more 3's. So I'm actually going to multiply this by 9. But I can't just throw a 9 down in there. I've got to balance it out. So actually, I multiply by 9 up here as well. And a way to think about that is that I've taken this fraction and I've multiplied by 9 over 9. This top 9 went out here. This bottom 9 is down here. So that's what I did there, just multiplied by 1. Now let's rewrite what we have here. So I've got 9 times negative 2. Well, that's negative 18. And then I've got the limit as x approaches 0 of, and this sine cubed 3x, I'm going to write that out separately. So each of these, sine 3x times sine 3x times sine 3x. And then on the bottom, I'm going to take 3x and write those out separately. So there's one 3x, another 3x, and another 3x all multiplied together. So I had 2 3's in there. There's my third 3. There's my 3 x's. Now you can see that we've got this chunk here, this chunk here, and this chunk here. And the limit as x approaches 0 of those chunks, each of them is 1. So this really comes out to negative 18 times 1 times 1 times 1, which equals negative 18. All right, let's try on with the cosine here. And remember, we're trying to find things in the form of 1 minus the cosine of x over x. Or in this case, since we were dealing with the cosine of 2x, we would look for 1 minus the cosine of 2x over 2x. We don't exactly have that up here. One thing we might want to do first is this top piece. You could change that into 1 minus cosine 2x by multiplying by negative 1. So if I multiplied by negative 1 on the top here, I'd have negative cosine 2x plus 1. I could rewrite that as 1 minus cosine 2x. So I think I'm going to do that. That'll bring a negative 1 out front. Then I've got the limit as x approaches 0 of 1 minus the cosine 2x over 2x times the cosine of 2x. Now, you might see already that this chunk right here would become our special limit. And the limit of that as x approaches 0 is 0. Another way to rewrite this to make this a little bit easier to understand, because you've still got this cosine of 2x hanging out down here, is to move this 2x up here. Another way to think of that is multiply by 1 over 2, or yeah, multiply by 1 over 2x over 1 over 2x. What that would do, let me rewrite this, is give me 1 minus the cosine of 2x over 2x on the top. And then on the bottom, this 2x and this 2x are going to cancel, so I'm just left with the cosine of 2x. Now this part is 0, or the limit of it is 0. And then we just need to figure out what is the limit of this bottom part as x approaches 0. Because if this is 0, that's going to blow everything up and this didn't work. But luckily, the cosine of 0 is 1. So the cosine of 2 times 0 is still 1. So we end up with negative 1 times, on the top of that fraction we've got 0, on the bottom we've got 1. Negative 1 times 0 over 1 is 0. So that's the answer there. All right, let's try one more. This one is going to be a bit tricky, and it may be something you haven't seen before. We've got the limit as x approaches infinity of 2x times the sine of 7 over x. We haven't seen 7 over x or some number over x in a limit, and we haven't seen x approaching infinity. The limit we know for sine is that the sine x over x as x approaches 0 is 1. So how do we handle this? Well, first of all, I'm going to take out this constant, this 2. It's just going to get in our way. So I'll pull that out, and then we have the limit as x approaches infinity of x times sine of 7 over x. Now the first trick that we're going to use here is that we want sine of something over something. So this x here, I'm going to convert that into a 1 over x and move it down to the bottom. So we have 2 times the limit of x approaches infinity of the sine of 7 over x over 1 over x. So if you're not sure how this x here turned into a 1 over x here, you can think about this as having an exponent of positive 1, and then we move it down to the bottom of the fraction, so that changes its exponent to a negative 1. Now, I have 7 over x here and I have 1 over x here. In our form of the limit, we have the same thing, x sine of x over x. So I need to multiply by 7 down here. So I'm going to do that. So there's a 7. I also have to multiply by 7 out here if I do that. The way to think about that is that I multiplied by 7 over 7. The top 7 is out here. The bottom 7 is down here. So now what I have, I'll just rewrite this one more time. 7 times 2 is 14. Then we've got the limit as x approaches infinity of the sine of 7 over x over 7 over x. Now this looks like we almost might be able to solve it because we've got the sine of something over something. We can't really solve it exactly the way it is because this still says the limit as x approaches infinity, and what we know is the limit as x approaches 0 of sine x over x. What we're going to do here is a substitution. I'm going to say that u equals 7 over x. And then I'm going to rewrite this. And the limit is actually going to change when I rewrite this. Think about what happens here with 7 over x as x approaches infinity. What does u become as x approaches infinity? You should know that it becomes 0 because you've got infinity on the bottom and some number on the top. So we can rewrite this limit as 14 times the limit of u as the limit as u approaches 0 of sine u over u. Now this is a problem we can solve because we know the limit as some variable approaches 0 of sine of that variable over that variable is just 1. So this becomes 14 times 1, or 14. And that's how to solve that one. So that's a little bit of work with some special trig limits. My name is Larry. I'm a teacher at EdVisions off campus. It's an online project-based school in Minnesota. If you're interested, you can find us on the web at lovethisSchool.org. Thanks.